Hey everybody, my name is John McElroy, and I'm the president and CEO of CaptainSpeak, and we are training providers in the Sea Ray aircraft. That's all we do. And I want to spend a little bit of time with you right now to discuss several very important things. And as a bonus, if you'll spend this time with me at the end of this, I'm going to teach you 5 big things that you need to know to eliminate 90% of all the Sea Ray incidents and accidents that we've seen occurring. So I think if I told you that, you'd be interested, wouldn't you? So as promised, I'm going to now teach the 5 biggest reasons for Sea Ray incidents and accidents. Over the course of the 10 years of doing training, we've seen so many scenarios and some of the issues that pilots have problems with. Sometimes they end up in having incidents, sometimes it's an accident, and some of it has even caused death. So if I'm going to prevent your death or prevent damage to your airplane or some of your passengers or even yourself, you're going to need to be vigilant about these 5 things. All right? Number 1, common in all seaplane incidents and accidents, and specifically in the Sea Ray, is landing in the water with your gear down. We have the unique opportunity in this platform to prevent that scenario. It's the number 1 reason for incidents and accidents, and the number 1 solution to that problem is right here in the Sea Ray. We can physically see our wheels and landing gear position if we simply will swivel our neck 90 degrees and physically look at the left gear being right there, and physically turn 180 degrees and look at that right landing gear right over there as well. Don't rely on switch position or 2 lights to indicate what the gear is actually doing. You need to physically turn your neck 90 and 180 degrees and visually identify that your wheels are physically up. That brings me to the second point. Don't fly a Sea Ray without the wheels up. There's absolutely no reason for you to be operating, even in the pattern. That's a mistake for you to be getting a positive rate of climb. You need to put those wheels up, and those wheels need to be identified by physically looking where they are after that switch has been moved. A lot of people will say to me, well, I'm just flying around in the pattern and I'll just leave the gear down because it's so much work. That's the error chain setting up right there. We see this all the time, and what will happen is you'll leave the pattern and you'll head out over to the lake, like here in Central Florida. We'll stay at Orlando North, and people will run out to the Lake Apopka, or maybe to the retention ponds, or up to Tavares to get some fuel. And they'll be flying because they've been in the pattern with their gear down. And there it is. They set it up, and they only confirm with their eyes on a pair of lights. Those are rumor. This is fact. If you turn and you swivel your neck 90 degrees, and again 180, you will prevent the number 1 reason for incidents and accidents, and in this case, the number 1 reason for death in a Sea Ray. Don't do it. Positive rate of climb, gear comes up, visually identify that your wheels are up. All right, number 2, coming in at number 2 of the big 5, is we have a weight and balance issue. And what's interesting is its weight and balance is sort of ironic, because it's not so much a weight issue. This thing will lift a ton. It's more of a balance issue than anything. Pilots tend to fly outside of the balance envelope for their Sea Ray. In our past, we've been taught that it's an aft CG issue, where I kind of run out of stick pressure. I don't have enough elevator control to overcome a rearward CG, and my inability to lower the wing's angle of attack during a stall. That's the thing that really gets in our heads. I certainly have talked to other people, and I remember that well from my primary training back in the day. But it's not really that problem for us in the Sea Ray. It's more of a forward center of gravity location. If I'm outside the forward envelope, or I'm up against that forward edge, what we see is the beginning of pilot-induced oscillations, and there's a momentum over the main gear that causes that. And it's that elevator, same thing, the elevator becomes ineffective against being able to pull that nose up or push it over to counter the PIO that's happening with a forward center of gravity location. So one of the scenarios that sets up, you have 2 people, you're having a good time, you've been flying around your friends all day, you're low on fuel. Now you have a CG location that's been slowly moving forward all day, and now you're at the forward envelope and even exceeding it in some instances. That sets up for the PIO, and everybody who knows that is trained with us, we have a 3 bounce rule. You won't see number 4. All right, so number 3 coming in at the big 5 reasons is energy management. Okay, we are seeing pilots that are just not used to flying high lift but high drag configuration aircraft. And that's what we have in this particular instance. We have incredible performance with the lift that's being generated by these wings, and a lot of power created by this very lightweight and very powerful Rotax engine system. It will take off in the shortest distance you have ever seen, and it'll climb like a homesick angel. But along with that kind of performance is a drag penalty that bleeds the speed off so much quicker than any of the other aircraft you've ever flown. So if you're coming from the general aviation world of Cessnas and Pipers, or maybe even the light sport arena where you've been flying a Tecnam or some of the very low drag and very high performance but very low drag compared to the Sea Ray, you will be rudely awakened by the speed at which your airspeed bleeds down. And that energy management is something that people aren't used to, so they'll either lose an engine, for instance, or they'll be on a final glide and they'll expect an ability to flare the aircraft out, and the energy just won't be there, and so they bang it on and they begin to induce that PIO. So we see that energy management and the speed at which the aircraft will bleed its energy down as the number 3 biggest reasons for incidents and accidents. Coming in at number 4 on the incidents and accidents is tailwheel operations, and specifically short coupling. An example of short coupling is the relationship of the roll when it is combined with yaw. So it's the way that aircraft will fly well in its coordinated flight. An example of short coupled aircraft would be a sailplane or a glider, where it's got this huge wingspan versus the length of the fuselage, but specifically where it rotates around the fuselage to the distance back to the tail. So with the Sea Ray, we've got a 30-foot wing or 2 15-foot halves versus about 11 feet back to the vertical and horizontal stabs. So when we have that 15 to 11 foot throw, we get a short coupled scenario where it's 50% of the mass, literally 50% more mass out there in the wingtip versus my ability to control it with my vertical and horizontal stabilizer. So short coupling, when it comes down to the tailwheel operations and that mass out there, really throws a lot of people off. I can't tell you how many times we've seen incidents where guys are off into the weeds off the side of a perfectly good runway because they didn't manage their short coupled and the energy that's in that inherent mass out there. So number 4, short coupled and tailwheel operations. Coming in at number 5, the number 5 of the 5 biggest reasons for incidents and accidents is exceeding a limitation, and that's twofold. There are aircraft limitations and there's personal limitations. When it comes to the aircraft limitations, we've set these numbers for airspeeds, bank angles, and G-loading from flight testing. I personally did it. With Demir, our aeronautical engineer, we worked with different kinds of airfoils, and we identified the speeds at which this airplane should fly. And those airspeeds are specific, and we're using ASTM standards to certify the LSX now. Part 23 and Part 25 airplanes from the general aviation world and even for commercial operations, that is a different set of engineering standards. And so what you may think is built in, that maybe you have this opinion that there's a buffer that's built in, well, that is true for those types of airplanes, but I wouldn't rely on that so much as you may have in the past. Trust the numbers that are inherent in the limitations in your pilot operating handbook, and you'll stay on the good side regarding exceeding the limitation. Just don't do it. All right, so know your airspeeds, but the really big one is the personal limitations. We see so many people just simply exceeding their personal limitation, thinking that, okay, well, I'll just get away with it now. The big one is wind speeds and direction. So whenever we do training, we always identify the first 15 hours of your solo operations when you're out on your own. We break it up into 3 5-hour increments, first 5, second 5, third 5, with 5 gusting to 7, 7 gusting to 10, 10 gusting to 15. And at no time are the gust factors more than 50% of the constant. So you can see that 5 gusting to 7 is a 2-knot gust factor, 7 gusting to 10 is a 3-knot gust factor, 10 gusting to 15 is a 5-knot gust factor. And now we train in more than 15 knots, but I personally don't fly sea rays when the wind is blowing more than 15 knots. It just isn't as much fun as when it's very light and you know, not so gusty. I have to work my tail off sometimes to get the airplane back down on the ground. Sea conditions really aren't that good, and certainly having those switchy, gusty winds with tailwheel operations makes it more difficult, much more challenging. So while we do training in those kinds of environments all the time, if I'm talking to you about your personal limitation, remember those first 15 hours are going to be broken up into 3 5-hour increments. Give yourself the time to build a solid foundation on top of which you'll understand what this airplane is doing by itself, rather than trying to figure out whether that was the wind blowing you around or whether that was the airplane and your ability to control it. So 5 biggest reasons for incidents and accidents eliminates 90% of any of the problems that other people have had. So be vigilant about either practicing or avoiding those elements, and you'll have more fun flying your Sea Ray. So I really appreciate your attention for this. Remember, the Sea Ray Flight Instructors Association is a factory authorized training program. You need to speak to a instructor association member instructor in order to get qualified for your insurance or for your Sea Ray and basically for your peace of mind. So I look forward to seeing you guys personally. Let me know by giving me a call or sending me an email what your questions are. I'll definitely steer you in the right direction, and we look forward to seeing you down here in Florida and doing some training with you in your aircraft or on ours. So thanks for watching once again. We'll talk to you later.